All right, so here we're going to work on finding and proving zeros of polynomials. We'll be using the graphs, synthetic division, factoring, and like basic solving skills for quadratics for the most part. Here's our quadratic formula here. So if you're allowed, you should begin looking for solutions to a polynomial by looking at the graph. You know, here's your x-intercepts. I can see there's 3 of them. This is x to the third. So I know that they're all going to be real, right? So if you see 3 x-intercepts and it's x to the third, you're like, oh, 3 real solutions. And, you know, you have to figure out and prove what they are. Now here, I see 2 x-intercepts, but it's x to the fourth. So what that tells me is that I'll have 2 real solutions and 2 imaginary solutions. It's important to note that imaginary solutions always occur in conjugate pairs, because really, you know, they come from the quadratic formula and having a negative under the radical, so you're always going to have that plus or minus. So your complex solutions might be like 3 plus or minus 2i or something like that, but that plus or minus will always be in there. And then looking at this last one, I see 3 x-intercepts, I see x to the third, so all my answers are real. I can tell this is 4, but these 2, I'm not quite sure what they are. These 2, they do look like they're opposites of each other, the same number, but 1 plus and 1 minus, but we'll figure that out. Okay, so there's the rational root theorem that tells you all of the things to try. So this is basically, if you can't look at the graph, then what you end up doing is this. You take all of the factors of the coefficient at the end, the constant term, and then you take all of the factors of the leading coefficient and you divide them. So all the possible rational zeros are this, everything that multiplies with 28. So like plus or minus 1 and plus or minus 28, plus or minus 7, plus or minus 4, plus or minus all the integers that multiply to 28, 14, and plus or minus 2. And then all the things that multiply to 2, the leading coefficient. And what this does is it makes a list of numbers. So like if I was going to write this list out, I have 1 over 2, so plus or minus 1/2. And then plus or minus, then I have 28 over 2. Well, 20 over 2 is 14. And so on. So you could go and you know, like pair these off and make a list of them all if you needed to. But these are numbers to try to put in your synthetic division. These are like possibilities if you can't look at the graph. But here I can see I can look at the graph. So what I'm going to do is I'm going to notice that -4 is one of the zeros. So let's put -4 in our synthetic division. Now, if this comes out to a 0 remainder, then I know I'm correct. If it does not, then it's not -4. All right, so it did. So that checks out. So let's go ahead and I see another one, +1. So let me just put +1. I'll just stack it on there. And another 0. So notice what happened is that like it kind of dropped down a level, right? Also, I was able to put the 1 into what was remaining from the -4. All right, and so what happened here, this was x to the third. I have just knocked out 2 x's, so that means I only have 1 x left. So this is going to be an x here. So my last answer is going to be 2x minus 7. I will set that equal to 0, and I'll solve for the third root. So this is 2x minus 7 equals 0. That means that x equals 7/2. Well, 7/2 is 3.5, and that makes sense. So my zeros are -4, 1, and 7/2. My factors are x minus 4, or plus 4 that is, x minus 1, and right here is the last factor, right there. So 2x minus 7. So these factors mean that if I multiply them back out, I will come back to what I had in the original. All right, so over here, so that was, you know, I did a synthetic division twice, and I was able to see the last one there. So I see -1 and 4, so we're going to go with that, put it through. All right, hang on a second. All right, 1, -8, -20, -20. So I see -1, 9, So something's wrong here. I don't think anything is wrong with my problem. Just give me a second. And I don't think anything's wrong with my synthetic division. Oh, what's wrong with my synthetic division? I bet you were screaming at me. I am missing an x to the third term. So you see how my remainder is not coming out to 0? And I'm like, uh-oh, something's wrong. So that means I messed up. So good, that happened. All right, so I have -1. I have 1. There is no x to the third, so -8, -27, and -20. All right, now it should work. So 1, I get -1, -7, 7, -20, and there we go. All right, phew. All right, so now the next one I'm seeing is 4. It doesn't matter what order you do those in. You can do 4 first and then -1, doesn't matter. So 1, and the zeros I see are -1 and 4. Up here I saw -4 and 1. Let's see, 4, 3, 12, I get 5, -20. Oops, that's a positive 20, 0. All right, so I've taken out 2 x's. That means I have x squared and x. So what I have left right here is x squared plus 3x plus 5. I need to find the zeros from this. I need to figure out when this equals 0. I don't see the answers on the graph, so I know they're going to be imaginary. So if they're imaginary, that also means I can't factor them, right? And so I'm going to need my quadratic formula. So my quadratic formula, I get -b, so -3, plus or minus a square root. I'll do the discriminant in a minute. The bottom is 2 times 1, so 2. So my discriminant value is 3 squared minus 4 times a is 1, c is 5. So it's 9 minus 20, so it's -11. So that means that it's going to be, I have an I there. So my zeros are this, -1, 4, and -3 plus or minus I radical 11 over 2. Now the factors, -1 is x plus 1, 4 is x minus 4. Now, I would put them right here and right here, but I'm kind of out of space. So my factors for that quadratic formula answer, like this ugly answer here, I'm just going to put x minus and then put one of them, -3 plus I radical 11 over 2, and then x minus again, and then -3 minus I radical 11 over 2. So anytime you have a weird answer and you want a factor, you just put x minus and then you put the item behind it. Okay. Now one other thing to mention up here, right at this point, I had x squared, right? I had x to the third, and I had taken 1x out, and I was left with x squared. So you can do one of two things at this point. I saw another good answer, so I went ahead and did the 1 through there. But here I could have also done this. Taking out that -4 leaves me with 2x squared minus 9x plus 7. I could have also set that equal to 0 at that point and tried to factor it, or done the quadratic formula. If you factor it, you get 2x and x. And let's see, if you put 7 and 1, that's 2x and 7x. If they're both negative, that makes my -9x and my positive 7. So that's also another way to do this. Like once you're down to 2 solutions, like a quadratic, you have so many ways that you can solve. All right, last one here. So the zeros that I see very clearly, the only one that's very nice is 5, right? So let's go ahead and do 5. Oops. Oh, that's correct, sorry. 1, -5, -6, and 30. So bring my 1 down, get a 5, 0, 0, -6, -30, and that one's good. All right, so let's test it out. I got x squared, and that's x. So what I have to do is I have to set this equal to 0. I have x squared minus 6 equals 0. I do know the answers are going to be real, so I don't have any i's coming up with me. But this right here, I'm not going to factor. I don't need the quadratic formula. Really, all I have to do is add 6 to both sides, get x squared equals 6, and do my square root. So my answers are plus or minus radical 6. So my zeros are 5 and plus or minus radical 6. My factors are x minus 5, x minus radical 6, and x plus radical 6.